Hello there, fellow mathematicians. This is Mr. Boyd, and welcome to Algebra 1. In today's lesson, we want to look at solving equations. So to begin with, let's look at our vocabulary. An equation is a mathematical sentence with an equal sign. A solution is the number that makes an equation true. That number would replace the variable in the equation. An open sentence is an equation with one or more variables, and a variable is a number or symbol that represents a number. Okay, let's take a look at the strategy we're going to use for solving equations. First, we need to identify what operation is being used on the variable in each equation. Next, we're going to perform inverse operations to both sides to isolate that variable. And then we're going to simplify the answer if necessary. For instance, if we have a fraction. And last, we'll need to check the solution. Okay, so let's take a look at a couple examples here. You see I've got several. Okay, our first one is x plus 3 equals 5. So the first thing we notice is that 3 is being added to the variable. So to undo that, we're going to perform the inverse operation of subtraction to both sides. And the reason we do that to both sides is because this is an equation. The equation must remain balanced. We'll simplify that, and x equals 2. Notice I cross out the 3 minus 3 because 3 minus 3 is 0. Okay, in the next problem I can see that 15 is being subtracted from the x. So the inverse operation of subtraction is addition. So I'll add 15 to both sides and simplify that. That gives me a solution of 112. And if I plug that 112 in for the x, I see that 112 minus 15 is in fact 97. In the next problem, 5x represents 5 times x. So in this problem, to perform inverse operations, I'll divide both sides by 5. 25 divided by 5 is 5. I cross out the 5 divided by 5 because that gives me 1x, and 1 times x is x. 25 divided by 5 is in fact 5. Okay, again I see I've got multiplication here, so I'm going to divide by 4. Cross out the 4's because they divide each other out. 12 divided by 4 is 3. Alright, on this problem, as I read the problem, I see this is x divided by 3 equals 3. So to undo division, I need to perform the inverse operation of multiplication. Now I show multiplication by using parentheses, not using the dot and not using an x, and I expect you to do the same. So if I were to multiply this out, this would be 3x divided by 3. So those cancel out because 3 divided by 3 is 1x again. And 3 times 3 is 9. And then if we investigate that by plugging the 9 back in to check it, 9 divided by 3 actually is 3. So this checks out, and 9 is the solution. Notice that 9 made this statement true. Okay, the next one we have is x divided by negative 5 equals 15. So to undo that, I need to multiply both sides by negative 5. Again, I'm going to use my parentheses, not a dot, not a x. Okay, negative 5 divided by negative 5, I'm going to cross those out, leaving me 1x. 15 divided by negative 5 is negative 75. All right, now moving on to the next problem, I notice that the next two are actually two-step equations, which means that there have been two operations combined into these. This one has multiplication and subtraction. This one has multiplication and addition. So I'm going to have to perform two steps to undo what's been done to this equation. So the first step is to add 21 to both sides. When I simplify that, I need to bring my 9x down. 87 plus 21 is 108. Next, I'm going to divide by 9, which leaves me a solution of 12. And if we go all the way back to the beginning, substitute that 12 in. 9 times 12 minus 21 is in fact 87, so this checks out and 12 is our solution. Moving on to our last example on this page, I see I've got addition, so I'm going to subtract 4, leaving me 2x equals 22. Next I'm going to divide by 2, which leaves me with x equals 11. I plug that back in up here. 2 times 11 plus 4 does in fact equal 26. So 11 is in fact our solution. Notice on these last two problems that I worked backwards through the order of operations. Order of operations is PEMDAS. And in PEMDAS, AS is the addition subtraction portion. Well, I'm going to do that first when I'm looking for part of the problem instead of looking for the answer. The answer here is 87. Okay, let's look at now how to solve a multi-step equation, because up until this point you should have already learned how to solve one and two-step equations. So we're going to go ahead and move into solving multi-step equations as well. First off, you want to simplify both sides of the equation, which means perform the distributive property and combine any like terms that you may have. Next, you're going to solve the one or two-step equation that you have left. And of course, you're always going to finish up by checking your solution. So here's our first example. 8x minus 2x equals 48. So first I'm going to simplify 8x minus 2x into 6x. And then I'll divide by 6. And 48 divided by 6 is 8. If I plug that back in, I need to plug it in for both x's. So that would be 8 times 8 is 64, minus 2 times 8 is 16. 64 minus 16 is in fact 48, so 8 is the correct solution. All right, here's our next example. Now here I see I have like terms again, so I need to perform 10x minus 6x to combine those like terms. That's going to give me 4x minus 3 equals 9. Next, I'll add the 3 to both sides, giving me 4x equals 12. Then I'll divide by 4, leaving me with x equals 3. Again, to check this, I would need to go back to the original equation, plug the 3 in for each of the x's, and make sure that that in fact gives me 9. So 10 times 3 would be 30. Minus 3 is 27. Minus 27 minus 6 times 3. Well, 6 times 3 is 18. 27 minus 18 is in fact 9. And moving on to number 3, I see I have a set of parentheses here. Well, our order of operations would tell us to do the parentheses first, except I cannot add these two terms because they're not alike. So I'm going to perform the distributive property first. So I get 12x plus 20. 4 times 3 is 12. 4 times 5 is 20. Next, I'm going to subtract 20 from both sides, giving me 12x equals 0. And yes, you can get 0 over here. Divide by 12, and x equals 0. So if I plug that back in here to check it, 3 times 0 is 0. 0 plus 5 is 5, and 4 times 5 is in fact 20. Therefore, 0 is the correct solution. I hope this helps, folks. Go on and work on your in-class assignment, and then there will be another video later.